Okay, YouTube, in this video we're going to highlight the relationship between the turning points for a polynomial function and the degree of a polynomial function. There's definitely a connection there. So we say that there does definitely exist a relationship between the degree of a polynomial of degree n, we'll just say in general here of degree n, relationship between that and the number of turning points that it has. And we say that any turning point occurs wherever the following occur. Basically, whenever our graph goes from increasing to decreasing. So if we were to have some polynomial function here that went from increasing to decreasing right there, this relative maximum point here would be what we refer to as a turning point. And then we would say also along the same lines, if we went from decreasing to increasing at any point on the graph, we would have this point here that we would refer to as a turning point. One thing that is not a turning point is, say, a cubic graph like this technically goes from increasing to like zeroing out here and then increasing again. It went from increasing to increasing, but that's not increasing to decreasing, so we wouldn't say that it has any turning point right there. But what I want to do is basically these four functions right here, put them into a graphing utility. So we have a first degree polynomial here, a second degree polynomial, third degree, and fourth degree. So we could just go ahead and list their degrees here, first, second, third, and fourth. But talking about the turning points, and what I've done is I've already loaded these up into Desmos. So we say y equals x. Of course, when we look at something like this here, that we have a line that goes through 0, 0, but basically it's always increasing. So we would say, well, it never went from increasing to being decreasing anywhere, so it has no turning points. So we're going to fill that in on our chart over here. We say turning points, none. We're going to say none or 0 numerically here. And we say turning points on a second degree thing. Well, we know that second degree things are parabolas, and parabolas always turn around at the vertex. So we'd say it looks like this goes from decreasing to increasing, so there'd be one turning point total on this graph that is second degree. So we say one turning point. Now a third degree thing, this would be like a kind of cubic-y, but we could say, looking at this, well, now that's interesting. We have a graph that increases, then goes to decreasing. So right here we have a turning point, and then decreasing to increasing, another turning point. So this actually has two turning points on it, third degree polynomial. And then, last but not least, we say our fourth degree polynomial. What does this look like? And as I highlight this here, you can see that we go from decreasing to increasing. So turning here, increasing to decreasing, turning, and then decreasing to increasing, turning. Three turning points on this fourth degree thing. So what I'd like to do is make a conjecture about the degree and the number of turning points. And I hope that you're seeing that the rule is that the maximum number of turning points, and I say maximum because just because we say it has this many possible turning points doesn't mean it actually will do that. But we'd say that given a polynomial of degree n, what could be said about the maximum number of turning points? We say that the number of turning points, and right here, let's write max. The number of max turning points is n minus 1. And I want to say that within the context of the degree is n. So whatever the degree is, you can write yourself a note here also. It's always 1 less than the degree is the number of turning points that a graph could have maximum on that function. So as we go back over to, say, Desmos here, I'm looking at some functions that I had typed in earlier, something like this fifth degree polynomial here. But I noticed that it has just one turning point, two turning points on there. So when we say it has at most 1 less in degree turning points, maximum, this is fifth degree, and so it would have at most 4 turning points on the graph. But if it doesn't have 4 turning points, and this is something we want to note here, then it goes down from that by an even integer, by 2's, let's put it that way. Okay, so it could have at most 4 turning points, but if it doesn't have 4 turning points, then it could have 2 or it could have none. Let's say a 10th degree thing can have at most 9 turning points, but if it doesn't have at most 9, or if it doesn't have 9, it could have 7 or 5 or 3 or 1. But you always count down by 2's from the maximum number that you can have. But important to recognize the maximum number of turning points that something can have. Cheers.